It's truly my pleasure to be with all of you this evening, those of you who are in the room and those of you online joining us through live streaming as well, to this welcome to our inaugurating Professor Aharonson. Let me say a few words up front, and that is that tonight is really a moment when the university formally and publicly and very proudly acknowledges the personal achievements of a scholar as he or she attains the apex rank in the academy. The apex rank in the academy being the rank of the full professor. It is the zenith of one's academic trajectory in some ways in the formal sense. Of course, we expect much more of you still, Professor Aharonson, and we know that there are great things to come. So this is not the peak of your career, but it certainly is the zenith or the apex point in the rank attainment inside the university. It's a really important opportunity for us to acknowledge your achievements, not only in the university, but also in the broader public domain. And so the inaugural lecture is normally open to any member of the public as well. It's free of charge, anybody can attend, and it's really an opportunity for anyone to share in the knowledge and the scholarship of the inaugurating professor. But this is also a moment in which we can acknowledge that this achievement is never purely only about the professor. It is in fact reflective of immense amounts of investment, support, mentorship, sacrifice, and care that has often been shown by colleagues, collaborators, friends, family. And so we use this opportunity to really collectively share in this moment, to celebrate with a communal sense of pride in the achievement that one of our own has attained, that of course also reflects upon us as a community. Professor Aharonson, we look forward to celebrating with you and experiencing your thoughts about your topic this evening, which is really on speech, rhythm, and blues. It's a fabulous, fantastic topic. And so I'm really looking forward to it. The inaugural lecture normally involves a full professor sharing with colleagues and the broader public their body of work, the future of their work, or a combination of these. Professor Aharonson, so even though it brings with it a sense of anticipation, I'm saying to Professor Aharonson earlier, you know, sometimes people are anxious, which is really on speech, rhythm, and blues. Love to lecture. So fabulous, fantastic. It does sometimes bring with it a sense of anticipation, really but just remember that everybody who's here tonight really wants to be a professor sharing, care about you with and they support you and they're interested in your work. So please do enjoy this as a celebratory event more than anything else. Without belaboring my opening remarks, let me formally call on the Dean of the Faculty of Engineering and Built Environment, Professor Thokozani Majozi, to introduce our inaugurating professor. Professor Majozi.
Greetings, everyone. It is my honor to read the bio for Professor Vered Aharonson, who has been introduced by the DVC for People Development and Culture, Professor Garth Stevens. Professor Vered Aharonson holds a Bachelor of Science and a Master of Science degrees in physics from the Technion in Israel, and also a PhD in physics and electrical engineering from Tel Aviv University. She was a research fellow at the Eaton Peabody Laboratory at Harvard University in Boston in the US, and having served as a senior lecturer in computer science and software engineering departments at Tel Aviv University, she went on to be an associate professor in medical engineering and electrical engineering at Afeka Academic College of Engineering, also in Tel Aviv. Prof. Aharonson was the founder and CEO of NextSig, Neurological Examination Technologies Ltd, and co-founder and senior researcher of the Afeka Center for Language Processing, the ACLP, in Israel. On relocating to South Africa in 2015, Professor Aharonson joined the School of Electrical and Information Engineering at the University of the Witwatersrand as the associate professor and was promoted to full professor in 2021. Her research involves physiological signals and speech processing for medical diagnosis, biometrics and behavior recognition, rehabilitation robots, and affective computing. In addition to her stellar academic career, Prof. Aharonson is a qualified pilot and engages in air ambulances and special mission flights. Thank you. May I call upon Prof. Aharonson to give us the lecture.
So thank you, Professor Stevens, Professor Manjosi, Professor Trengov, Dr. Masisi, and all of you online who are joining me here for my lecture on, indeed, speech, rhythm, and blues, which is actually about speech, science, and music. So why music? Well, I let bigger men than myself say it for me. Shakespeare, in Count Orsino's words, in the 12th Night, said, "If music be the food of love, play on." So let's play on. And music and science were always connected, even in the first academia in ancient Greece, where Plato and his student Aristotle were studying music in the context of the natural and the social sciences. They even went as far as define special moduses. The modes were the ancient Greek music scales for different actions of people. For example, a certain mode should be played to a soldier going to battle. Another mode should be played to a man going to a woman. So Shakespeare was right on the spot in Count Orsino's words, because music is indeed the food of love. And as for myself, music and science and physics were always connected in my life. I will let you all into a secret. My first academic degree and academic career started in the Academy of Music in Tel Aviv University in the piano department, and then on scholarship in London with Professor Peter Feuchtwanger from the RADA. So then when I moved to the physics department after my military service, the transition was really very natural to me and straightforward, because physics, just like music, has the same elements. It's symmetry and asymmetry, order and disorder, harmony and structure. So it all felt very natural. And since in science we always put a proof to our statement, let me prove it to you, the relation between music and physics. So I will let the music speak for me in this proof. This is a canon of Johann Sebastian Bach from the musical offering. It's BWV 1079. And let's listen and observe the physics. Now, symmetry. Playing it the other way around, we get to the same solution. Now combining to create a harmony. before the second part of my proof, I'll need to define something mathematically. So here are some props. This is a ring, one ring to rule them all. Okay? And a ring has two surfaces, an outer surface and an inner surface. So if I were to trace the surfaces, I will need to first trace the outer surface, then lift my marker and trace the inner one. Now, if I were to cut the ring into two parts, this way, I'll get two rings. Now, there's another sort of ring called the Möbius ring. Möbius rings goes like this. Let me stick it out for you. Now, the Möbius ring has only one surface. It doesn't have an inside or an outside. Again, prove it to you. This is physics. Okay? So starting from this point, I can go along and trace it from the outer side. And get back to the X. One surface only. And if I were now to cut this ring into two, in the same way, one ring. Okay, one surface, one ring. So let's see what Johann Sebastian Bach does from this math puzzle. Cut in the middle to make the ring a little bit smaller. And Möbius. Isn't it beautiful? All right, so the music I am interested in is the music in the human voice. And it has many applications, because the human voice contains lots of information about the speaker, about identity and language and age and gender and even feelings. So my research is about quantifying those elements in speech that can convey this information automatically or to be done by machines. Because engineering that goes after science is solving a problem. Now, what is the problem here? We as humans have brains that were trained and tuned for millions of years of evolution to listen to each other and to understand this information. But sometimes we do need machines to help us in listening in many circumstances. So we need to teach the machine to do the listening and extract the information just as we do, or at least close to. So we have security applications and military applications and medical applications and even social applications that need machine out there to do the listening. Okay? And this is not an easy job. It's not as easy to humans to listen to each other, and it's even harder for machines because we have many more inputs. compared to a machine that just listens. We can use facial expressions and body movements and lip movements. Now, in the time of the pandemic, many people discovered that they have hearing disorders just because they couldn't read lips anymore because of the masks. Now, our brains are wonderful at filtering noise, especially when a voice is concerned. So we can listen to each other and understand speech even in cocktail parties, or through bad communication channel, or under fire talking at PTTs. We can understand voice. Machines have a really hard time doing the same. Likewise, we can figure out what's being said and who spoke and why, even if that someone has a cold or speaks in a different language and accent. We still can recognize all those stuff. Machines can't. And we are very good in finding context in the speech to allow for things that we do not hear. Again, machines are really struggling in doing that. So, in my research, I tackled this problem by mixing all kinds of knowledge from different disciplines. One of them is the music theory, but then also the speech production physiology. These are the organs and the systems in the body that produce speech. So understanding them and modeling them in kind of a source and filter structure really puts lots of information into the model. Then, of course, lots of data and some computational tools called signal processing and machine learning. I'll plant in this lecture a little slides called, which I call the library corner, which contain just a sample of my research in different topics. And again, it's just a sample. These are papers on more traditional speech and speaker recognition, where my focus was on speech in languages which are exotic or hard to collect data in. For example, some countries that, whose name ends with Stan. But I couldn't have done any of it if many wonderful people haven't come along to share the research and fund it. And again, like in the library corner, this is just a sample of the many people who were there for me and helped in doing the research. My main interest, though, was in speech for healthcare. Because again, speech conveys lots of information about the health condition, both physical and mental health of a person. And here, machines, or AI, let me call it by name, can really help the doctor in diagnosis and decision-making. And the main advantage of using speech for that is the speech is very cheap to collect. It can be collected anywhere by anybody in low-cost devices that are non-invasive and are accessible by everybody. So, speech is a really important tool in medical and healthcare sciences, or could be. Now, here, what is the problem of healthcare today? Once upon a time, doctor's appointment looked like this. Doctor really looked at the patient. Now, they most often look like this. So the poor doctors really need to struggle with lots of electronic records and deal with the computer and hardly look at the patients, but they do listen. So why not design some little digital helper that will help in the listening and provide the doctors with pertinent information that can help them in their decision-making? In all kinds of medical applications like diagnosis and monitoring and treatment efficacy and even digital intervention called virtual therapy. So speech can be used also as a feedback to help cure some diseases and disorders. And of course, when a large amount of people needs to be screened for some disease, for example, in the case of a pandemic, speech is a really important tool to be used. It's just an app, can be run on any cell phone and convey lots of information to the clinician. The library corner, some of my papers on disease diagnosis, Alzheimer's disease, Parkinson's disease, vocal cords disorders and pathologies, and of course, COVID. Here is some papers on rehabilitation and treatment, such as treatment of speech disfluencies and stuttering, using digital intervention. And again, wonderful people who were there to collaborate, help, and support these studies. And again, health is not only the physical things, but also the mental ones. And depression was called lately the silent epidemic of the 21st century. It's more prevalent than COVID is, and has grave consequences on people and their families. So here too, speech is a viable and even natural tool to use, because after all, what do psychologists do? They listen. They listen to information, both verbal but also non-verbal, or the music, information in the voice. And mental state is not only about diseases or disorders, it's just natural thing that we all convey and perceive from each other, and therefore lots of my research dealt with emotion recognition. This again can be used by machine to help us perform better in all kinds of situations, including business information, help us speak more clearly or with a better emotion and affect or mood in different circumstances, and of course understand and evoke emotions like in conditions like as Asperger and autism. In emotional speech, music really plays a big role because it's about intonation, pitch, and rhythm, and some blues. So the musical theory comes by and really help to analyze and understand all the intricacies, symmetries, harmonies, and structure in the voice when emotions are conveyed. There are some tools that we use in our research to do the trick, to harness this music and help it analyze and quantify those attributes of speech that convey this or that emotion. One of them is called analysis by synthesis. So we observe what is happening by synthesizing digitally the change of this or that attribute, and just listen or watch the outcome. For example, sorry, this was cut.
After I finish this section.
Now, in a tweaking of one element or one musical harmony, we get this speech. Right?
After I finish this section.
Okay. So you see, it's intonation. Again, this is not an emotional voice, but it's just a synthesized voice that conveys a different effect or meaning by changing an attribute called pitch. Another tool is modeling, where we assign quantitative numerical values to each one of those attributes in speech that we believe convey emotion. Now, these values are placed on a scale or an axis. There are many axes that can be used. This, for example, is an axis of positive, negative, active, and passive. And all the emotions can be planted there within this scale that was, of course, developed by psychologists. Many of these research were collaborated by and actually made happen by psychologists. And also, there's some dynamics there because emotion is not static. It changes as the conversation and the speech goes by. So we can actually plot a graph conveying the relation between changing of each attribute and the emotions that is reflected in the speech. These, for example, are two speakers that are engaged in relationship conversation. Some of the graph says it all. And of course, the magic tool, data. Now, Data is not only my favorite character in Star Trek, and he's a musician as well, but collecting data for these subtle tasks, such as emotional recognition, is really a big challenge. Because one of the things you want is that the speech will be spontaneous. Acted speech, even by good actor, was tried. It doesn't work at all when those models are applied on natural speech. So we want people to speak naturally and spontaneously and still convey emotion and still do it in a controlled way so we can actually record it and annotate it and label the distinct emotion in the speech. So we need to find those conditions in which people are apt to speak spontaneously with emotions. Three of these conditions are people interacting with pets, people interacting with the psychologists, and people losing or gaining lots of money. So I try to take those conditions and digitize them in a way that speech can be recorded while people are engaging in these situations or conditions. Take, for example, the gambling, which is the place where people do tend to lose lots of money. Okay? So this experiment was based on a psychological theory by Damasio and an experiment that was planned and labeled by a psychologist so that I didn't need to guess what emotions are out there. It's not just a gambling game that anybody can take from any place. So this game, played by Damasio using cards, was digitized in our research and placed on a computer. This twist of the design was also connected to the Monty Hall game. Okay? So people needed to open or close doors, and behind any door, they could lose or gain money. And of course, the game was voice activated. So people needed to say, open this door or close the door and move to the next door. So we had lots of utterances or speech saying the same verbal content with different emotions based on what the events in the game were like. Another experiment for data collection was SAL, the sensitive artificial listener that also rhymes with HAL, this wonderful computer in Space Odyssey. So I don't know if any of you remember ELIZA. It was one of the very first computer games, even in the 80s, where a computer was this thick and had one line of text running about. ELIZA proved to be a very good digital psychologist. People really got engaged with the game, although it was such a primitive user interface, and really tell ELIZA all their secrets and inner feelings. Now, we took ELIZA and put it into the 21st century mode. First of all, it was speech activated, so people actually talked with a digital psychologist, and also a twist in the design. We included also, again, to control emotions better, another game called the hat personality game. Do you know this game? It's a psychological kind of a game in which you receive a hat, say a red hat, and you have to be pragmatic. Or you get a yellow hat, you have to be happy. So in this case, Sal was the one that was changing the hats. And Sal could be sometimes happy and sometimes sad, sometimes prudent, sometimes spiky, and therefore could evoke more controlled emotions in the participating volunteers. And last, the AIBO experiment, again, a digital dog. It was one of the first digital dogs by Sony. Children interacted and played with it and were very happy in it. But again, to make it into a controlled data collection setting, we played with Aibo. So the children needed to speak to Aibo and control him by command, by voice command, to do certain tasks. Now we sat in the other room with the Aibo navigator and controlled Aibo to be sometimes obedient and sometimes to disobey the commands. So children were either very happy with Aibo or actually very angry. One of the things we didn't expect that many children really felt what we called, or psychologists called, motherless. So they really felt bad for Aibo, who is so stupid and can't do it. So they really spoke in a very compassionate, empathic way. So all these data sources really amounted to a large group of data sets that could then be analyzed and used for development of tools and models and application for emotion recognition. Some in this library corner, and of course, the collaborators. There's a website, Emotion Research, that is based on this experiment and many other research done in this topic. So, emotions and speech for achieving a goal, this can be very important in many other domains. In just social and educational and just communication between people. One of the first studies in this topic was done all here in South Africa with brilliant undergrads in the fourth year project at WITS, and the project was called Good Delivery of Bad News. Now, healthcare professionals are not only diagnosing and monitoring and deciding on treatment, they also need to interact with patients and families. And sometimes they really need to break bad news. So the question is, how can we model and understand and even help them to convey these bad news in a more emphatic and not pleasant, but better way for the patient? So here we used a recording from palliative care services here in South Africa and defined many attributes that can help those doctors and nurses to give a better delivery of bad news. Another project, also here in South Africa, dealt with how to communicate other bad news. In this case, for example, the news on COVID to a large amount of people digitally, and so that people will really be convinced to change their behavior and act responsibly. For example, wash their hands, keep distance. So you probably remember that many people came online and on the media. This data was supplied by NCA and talked about COVID and explained and said, come on, let's keep a distance, let's be prudent, let's wash our hands, etc. All these people spoke almost the same text, but some were received more and were trusted more, and some were not. So again, the question in this research was, what are the differences? How to convey this pertinent information, how to persuade people to really make a change by your address. And COVID has come and gone, or almost gone, but many other issues are here to stay. One of them is education. Education is still carried out in many countries digitally from a distance. It will be probably more and more so. People in businesses are communicating in a distance. And again, speech can be a very important tool to master in order to communicate better, in order to be a better teacher, in order to be a better speaker. And all this can be aided by AI technology. Some of these studies, again, effective learning, what is a charismatic lecturer, and other speech-based address or conveying of information, scientific information to people so that it really be effective and also pleasant to the listeners and the learners. And here again, sample of the people who took a part in these experiments and their research, and to the Erasmus Plus that is right now supporting and funding our project Be the Change. Be the Change is about educating people in classroom and out of classroom to be responsible on the topic of climate change and environmental sustainability. So it's not only about understanding what is climate change, but also to really take action and make a difference on your and other people's lives. Which brings me back to the environmental part of the faculty. So, skipping on another recent study on biomarkers for pilots' fatigue, and again conveying my history in which both music but also aviation played a very big role. So I was acting as a freelance airline pilot throughout my academic career, and therefore find as natural to find lots of interaction and correlations and connection between aviation and physics and engineering. But I want to end this lecture by talking about aviation and music, or actually letting the music say it for me. It's rhythm and blues. And last but definitely not least, thank you all my friends here at WITS for receiving me and becoming such good friends and supporting my science and myself. And thank you all for listening. This, by the way, is my niece, the next generation Airbus captain.
Thank you very much, Prof. Aharonson, for that wonderful lecture. I will need your services, by the way. I have 2 teenagers at home. I think I can use this tool to detect when someone is lying. So I think I'll need this. In fact, I was even thinking of seeing some polygraphs somewhere there in the presentation. Thank you very much for that wonderful presentation. I think we've learned a lot. We've always undermined speech. We forget the music below the speech. But thank you very much for that. I will now call upon Professor Dr. Lesedi Masisi to give us the vote of thanks.
Afternoon, everyone. Yes, I would like to thank you all for coming. Guests, Berit, the Dean, our head of school, and the Dean of Health. It's my first time to do a vote of thanks. So I was looking at the YouTube videos. How do people say vote of thanks? I even asked one of the dean here that, do you know how to do vote of thanks? And then he said, no, people are so different, they do it differently. So it's all on you. So I've been trying to capture some notes. But one thing I'm picking up from Prof. Vered's work is the use of a voice and combining that with physics to basically apply that into health, recognizing, basically diagnosing issues with regards to human behavior. And one of the applications that she mentioned is how about using sort of machine learning or AI or a tool that can do voice, that is based on a voice model to assist doctors to do diagnosis, which is very important because in certain rural places where you have grannies who can't speak well and so on, such tools becomes very beneficial to help diagnose with the doctors. But it's a very complex problem because there's cultures as well into this. She highlighted the challenge of data collection being a huge challenge, and fairly so. However, we can see that there is some light at the end of the tunnel. There is some impact of this work in improving a human life. And it's quite amazing that as she started, she spoke about music and physics. And I remember also Einstein actually used to play the violin. He liked the violin. So I've never imagined that music and physics, I know there's music theory and so on, but I've never imagined that music and physics can be married so beautifully. And given her accolades, physics background, and now using music, basically as a therapy. And the marriage, she's in the School of Information and Electrical Engineering. And you can see there was some synergy between psychology, there's synergy between physics and engineering, which is something very amazing. And I think that's the future, of science, where there's synergy across a board. This thing of working in silos with physicists and psychologists or humanities, there seems to be a marriage that is happening in with the goal of resolving issues related to humanity. So I'm very thankful, and I can see this huge impact of this work in the world. It has a mark. It's going to leave a prominent legacy. And we really thank you for enriching the School of Electrical Engineering as well with this new knowledge in the sphere of science. So thank you, ladies and gentlemen, and thank you, Prof. Vered, for taking the courage to pursue in this field and shaping certain knowledge that without you will not be there. So thank you very much.
Thank you very much, Dr. Masisi, for your insights. I know you're doing this on the trot, so to speak, as you're listening to all of this. But thank you so much for your insights and for your vote of thanks. As you were reflecting on what Professor Aharonson has just done, she's really traversed the fields of health, of physics, of music, speech, physiology, engineering, and psychology, all in one fell swoop. And I think that that's absolutely amazing. If one thinks about the way that we talk about, interdisciplinarity and transdisciplinarity, then I think what you are showing is the materialization of that idea in the work that you've done. And I say that as a psychologist myself. It was fascinating to listen to you. And so I think another round of applause is really due to Professor Aharonson. As is tradition once the professor professes, nobody gets to ask questions. And it's the one time I'm afraid that the audience doesn't get to ask questions. Normally as academics, we have a life of speaking and being interrogated, speaking and being scrutinized, putting forward an argument and having it debated and critiqued and so on. But on this particular evening, the inaugurating professor professes, and we leave it at that, and we ask that you take this outside and you engage with Professor Aharonson outside as we do a little bit of, I think there are some snacks and some drinks and so on. And so this does really conclude the formal part of this evening's proceedings. Would I ever again like to take this opportunity to congratulate our inaugurating professor, Professor Aharonson, to thank her, to thank Dr. Masisi, and all of you for attending this evening, both in the venue itself, but also to all of you who have joined online. It's really, technology is an amazing thing to be able to allow people who are unable to be here physically to still join in such an important moment in the life and the career of an academic. And so really appreciate all of you joining online as well. I'm going to ask that you all join us afterwards, just share in some conversation, engage with the inaugurating professor, have something to eat, have something to drink, just enjoy this cold Johannesburg evening, but hopefully it's a little warmer now that you've heard the stimulating thoughts from Professor Aharonson. So can I ask you at this point, again, all to just stand, please, and once the academic procession leaves the venue, again, I invite you all to join us in the foyer. But before we go, and I declare this inaugural lecture closed, can we have one last round of applause?